Good morning, students. See, in the previous videos, we learnt about the concepts of systems of particles and rotational motion, several concepts. See, especially center of mass, moment of a force, equilibrium, etc., etc. See, now on some of the concepts we will learn more solving MCQs. If you can solve some problems, then you learn more. Okay. So going to the, which is the concept we are learning now? Moment of a force. Okay. See that, of course, in the previous videos I had explained in detail. Moment of a force is also called torque. Torque equal to R cross F. Okay, if you want the magnitude, it is R sin theta into F or R into F sin theta. All these things we have learned. How do you apply that? Okay, look here. There is a problem. A door 1.6 meter wide requires a force of 1 Newton to be applied at the free end to open the door or close it. The force required to at a point 0.4 meter distant from the hinges for opening or closing. Okay, actually this what is the distance? What has happened to the distance? From 1.6 it has come to 0.4. It is 1/4. The distance is 1/4. Something like you got a door. Okay, so this has to be opened about this axis. Okay, if you apply the force at a greater distance, you require a smaller force. Okay, see now that's why in a greater 1.6 meter you require a smaller force 1 Newton. If you come 1/4 closer, you will require 4 times this, 4 times into 4. See, that is 4 Newton. 4 Newton is the answer. Okay. So moment of a force is R cross F. Okay, if it is theta equal to 90 degrees or torque equal to RF, that's all, R into F. Okay, so torque required is constant. If R becomes smaller, F should become greater. Okay, see, that's the concept. That's how 4 Newton. Okay, say now going to the next one. Okay, this is how we solve the problem. You can pause and learn. Okay, now again, so what is force is given, position vector is given. What is the torque about the origin? Okay, so as the previous we learnt, tau equal to R cross F. Okay, R cross F. Should find the cross product of the two given vectors. Straight away it's almost a problem on vectors. Okay, so okay, straight away how do you say R is given, F is given, R cross F is the determinant. You expand the determinant, you get the answer. So you pause and calculate yourself. So think which is the one. So 8 plus 10 plus 12. 8 plus 10 plus 12. Okay. So option B is the correct one. Now we will solve some problems on the concept of center of mass. Center of mass is x coordinate of the center of mass. We already learned m1 x1 plus m2 x2 divided by m1 plus m2, or okay, sigma mi xi divided by total mass. Okay, and similarly the y coordinate. Okay, I think it can be x center of mass. See, x center of mass can be integral m or x dm. 1 minute, it's not x dm divided by integral dm. If it is a variable mass. Okay, if it is a variable mass, so then you will use this relation x dm, where the small mass dm is at a distance x. So this formula also you can use. But anyway, if it is okay, See, center of mass is almost, say, we have learnt in detail. So if you look at the which points is likely to be likely position of the center of mass of the system as shown here. See, okay, one portion, half the portion is air and sand. You got sand. See, more likely or definitely actually the center of mass, if there were completely air or sand, it would be at the center. But okay, see, but because it is sand half the portion, so it will come towards sand. I think we had the greater the mass, closer to that point will be the center of mass. So therefore, option D. Okay, there is one more. Two particles which are initially at rest, move towards each other under the action of their mutual attraction. There is mutual attraction. This is the key word here. If their speeds are v and 2v at any instant, then the speed of the center of mass of the system. Okay, so this is mutual attraction means this is internal forces. Okay, there is no external force. They are not moving because of external force or external. If external is 0, if external is 0, say there is no acceleration of the center of mass. I think we had looked at a video also, boat and a woman, and so where because the center of mass should remain at rest if there is no external force, no movement. So that's it. So 0 is the answer. Okay, these concepts, some of these concepts we have learnt. So about center of mass we have learnt, torque, and we will continue more concepts in the next video. Thank you.